So in this first case, you'll be told, use Taylor's theorem to expand cos pi over 3 plus h in ascending powers of h up to the term in h cubed, isn't it? Now, which function are you expanding? In ascending powers of h, it means you are expanding the function x plus h, isn't it? Because that is when you get the ascending powers of h. Are we together? In ascending powers of h, it is the function f of x plus h. And we said that f of x plus h, if you remove h, you remain with f of a. If you change x, you get that. So it means when I want to expand ascending powers of x plus h, I start from f of x. Are we together? I start from f of x. So if you start from f of x, you go f of x plus f prime of x. You know you leave space where you are going to add that term which is left, isn't it? Plus f prime of x plus f double prime of x plus f triple prime of x. Why are you reaching f triple prime? Because you know when you have f triple prime is when you get h cubed. Are you seeing that? So you start, when you have f prime, it means it is over 1 factorial, then your h is raised to power 1, isn't it? Are we together? Are we together? Yes. Then you go here, if you have f triple prime, double prime, you have 2 factorial, then h is raised to power 2. If you have f triple prime, it means 3 factorial, then h is raised to power. Are we together? Are you saying you found your series? So you found the series up to the term in h cubed. So you found to get this series is very simple, the way I've stated it. So that is very simple. You just come the other way, you just come and say f of x plus h, they start with f of x. Then if you have f prime of x, then it means our h is raised to power 1, then over 1 factorial. Are you seeing that? Then you move again, when you differentiate it for the second time, f double prime of x, it means our h is raised to power 2 over 2 factorial. Are we together? Yeah. Then you move the next one, if you have f triple prime of x, then it means our h is raised to power 3 over 3 factorial. When it is triple prime, it means power 3, isn't it? When it is double prime, it means power. See, that is a easier way of mastering it. Yes. So, that is the expansion. I've reached the power h to power 3 is where they want you to reach. Okay? Having done that, what have you been told to expand? Cos pi over 3 plus h. So you don't start with cos pi over 3. This is your pi over 3 because it is supposed to be f of x plus h. Meaning, this your function f of x plus h is equals to what? Is equals to cos x plus h. Meaning your x is pi over 3. Are you seeing that? Your x is pi over 3. Tuko pamoja? Yes. Yes. So if you have cos pi over 3 plus h, they are trying to tell you pi over 3 is occupying the position where x is occupying. And my friend, let me say something which is very critical here. When you are dealing with the power series, the calculator must be in R for pi radians. Why must the calculator be in R? The calculator should be in R because if this function, for instance, is a trigonometric function, if let's say x, you cannot use degrees. When you use degrees, when you are getting maybe sin, let's say sin x, then h squared over 2. So if h is in pi radian, x must also be in pi radian because when you get something like sin 30 degrees. When you get something like sin 30 degrees, that is 0.5. You see this answer 0.5 is pi radians. Meaning if you put h to be in degrees, it is like you are saying pi radians times degrees, which is not working out. It is like saying when somebody gives you 100 meters times 10 centimeters, then you are saying that is 1000 meters centimeter. Are you trying to get what I'm trying to explain? Yes. Are we together? Degrees don't work here. Degrees never work here because the output is always in pi radians. So you must ensure that your calculator is always in radians all the time. That is when, because the output of the function will always be radians, so h must also be in radians. Meaning if you are told maybe to use it to evaluate maybe say 31 degrees, if you separate this to be 30 plus 1 degree, so that your x is 30 degrees and your h is 1 degrees. The moment you are going to get sin 30, the answer is going to be pi radians. And the moment you leave h to be in degrees, it means you are multiplying pi radians and degrees. Are you seeing? Which is irrelevant. So it means h must also be pi radians. Have you gotten the point? So h is not 1 degrees. You know very well that 180 degrees is pi, therefore 1 degree is what? Pi times 1 degrees over 180. Then you have changed these degrees into pi radians. So you can multiply them. Because the product, they are always as a product. Are we together? Is that well understood?
Yes.
Good. So, from there, remember we are looking for a function of x. Here we have a function of x plus h, meaning if you remove this h, if that h is 0, you remain with f of x is equals to cos. See, if h is 0, so you remain with f of x. Then yes, you remain with cos x. Because we are looking for f of x, so we are seeing how do we get f of x from f of x plus h, isn't it? Are we together? Because you can see f of x plus h you've been given is cos x plus h. Your x is pi over 3. Are we together? So when this h is 0, it means f of x is cos x. Because that f of x, we are very interested in it. Is that okay? So after getting f of x, we can now get f prime of x. If you differentiate f of x, if you differentiate cos x, what do you get? If you differentiate cos x, negative sin x. That is the outer function, isn't it? Then if you differentiate the inner function x, you get 1. So it is just this times 1, it is just that, isn't it? You must always use the chain rule, differentiating both the outer function and the inner until you reach the most inner function and you express them as a product, isn't it? Let us move on. When we differentiate it for the second time, negative is a constant, the factor is outside. If you differentiate sin x, you get cos x, isn't it? So we are now going to have negative cos, because remember that negative factor is outside. So when you are differentiating this sin x, you get cos x. So cos x times negative is negative cos x, isn't it? Are we together? We are getting all of them until we get f triple prime. Senor?
Yeah.
What is f triple prime of x? If you differentiate f double prime, you get f triple prime, isn't it? So f triple prime is what? If you factorize out negative, if you differentiate cos x, you get negative sin x. So negative sin x times this negative, positive sin x. See, you found everything. You found f of x, you found f prime of x, you found f double prime of x, you found f triple prime of x. Are we together? And if you look at this problem, what is our x? Pi over 3. So the first one is, what is f of pi over 3? Meaning where there is x, you put pi over 3, isn't it? That is going to be cos pi over 3. Your calculator must be in radians, r. So what is cos pi over 3? What is cos pi over 3? Cos 60 degrees. Calculator must be in pi radians, so put pi is in the calculator there. What is cos pi over 3? Which kind of calculators are these? Are you using here? 0.5. I move to the next one. Here is f prime of pi over 3. F prime of pi over 3 is what? It is minus sine pi over 3, isn't it? So go to the calculator, negative sine pi over 3. Negative sine pi over 3. These are special angles. They are things you are supposed to know often. What is negative sine pi over 3? You move to the next one. F double prime of pi over 3. Remember our x, because this is x plus h, meaning our x is pi over 3, isn't it? Where there is x, you put pi over. So f double prime pi 3 is negative cos pi over 3, isn't it? Which is negative 0.5. Move to the next one. F triple prime of x, and our x is pi over 3. X plus h. Our x is pi over 3. So f triple prime of pi over 3, sin pi over 3. You get 0.8. So have you seen we found all the functions, isn't it? So we simply go back to our formula and we substitute, isn't it? What is f of x plus h? F of x plus h was cos. Where we are substituting the values. F of x plus h is what? Cos x plus. So where we have f of x plus h, we put this value, which is cos x plus h, isn't it? So we have cos x plus h is equals to f of x. What is f of x? Cos x plus f prime of x. What is f prime of x? Negative sign x, then it is times h to power 1 over 1 factorial, isn't it? Then what is our f double prime of x? Negative. This one is negative cos x, isn't it? So we have negative cos x. Then it is times what? H squared over 2 factorial. You see? Then what is our f triple prime of x? You are just doing substitution, isn't it? F triple prime of x is sin x, positive sin x. Then it is times what? H cubed over 3 factorial. So you see we found cos x plus h, isn't it? But what do we need? We need cos pi over 3 plus h. So the next line, what is now cos pi over 3 plus h? Meaning, where there is x, you put pi over 3, isn't it? Are we together? Is that okay? Yes. So what is cos x? What is cos x? You found it to be? See, you are substituting these functions. You found it to be 0.5. Yes. 0.5 minus sin x. What did you get to be negative sin x? Negative sin x you found to be negative 0.86. Then h raised to power 1 over 1 factorial is just h, isn't it? Then you move to the next one. What is negative cos x? This negative cos x you found it to be negative 0.5. Then it is times h squared over 2 factorial. 2 factorial is just 2. Are you seeing? Are we together? Then the next one, what is sin x? This sin x, what did you find it to be? 0.866. Then h cubed over 3 factorial. 3 factorial is 6. Are we together? So can you now go to the calculator and give me the values? So cos pi over 3 plus h is equals to 0.5 minus 0.866h. Then start. 0.5 divided by 2. Then you have negative 0.25h squared, isn't it? Then 0.866 divided by 6. Because 3 factorial, you can just say 0.866 divided by 3 factorial. It's still the same, isn't it? You get? 0.144, then h cubed, and you are done. You've expanded cos pi over 3 plus h in ascending powers of h up to the term in h cubed. Are we together? Are we together?
Yes.
So have you seen how this power series is very straightforward? The power series is very straightforward and very simple.